Find the four smallest positive integral values of a so that the equation ax squared minus 2x minus 3 equals 0 has rational roots. Now, same thing as with the a problem. To determine the type of roots or the number of roots, we look at the discriminant. So the discriminant is the part underneath the square root sign with the quadratic formula. So we're looking at the b squared minus 4ac. Okay, so we're trying to find a so that your discriminant will create rational roots. So for the rational, what I need is perfect squares. So for example, if your discriminant is say 25, well, square root of 25 is 5, which is rational. If your discriminant is say 26, well, square root of 26 in the quadratic formula would give you a irrational number. So I need to have b squared minus 4ac equaling a perfect square. So b we know to be negative 2, and then c is going to be negative 3. So when I plug this in, I'm going to get negative 2 squared minus 4 times a times negative 3, which gives me 4 plus 12a. Now 4 plus 12a, we said, would have to be a perfect square. So we trial and error with different numbers, plug in a 1, plug in a 2, plug in a 3, keep going, until we find the four smallest values of a to get a rational number. So plug a 1 in for a, I get 12 times 1 is 12, plus 4 is 16. That's a perfect square, so that would be one solution for this. So a would be 1, would give me a rational number. If I plug a 2 in, I'm going to get 28, which is not a perfect square. Plug a 3 in, I get 40, which is not a perfect square. 4, I get 52, not a perfect square. 5 would give you a perfect square, give you 64, and that would work, so 5 would work. And I keep trying different numbers, so plug in a 6, plug in a 7, those would not work. 8 would work. I'd get 100, square root of 100 is 10, which is rational, so 8 would give me that answer. Keep going, and your next one would be 16. And so your first four would be 1, 5, 8, and 16.